Hello friends, welcome back. In this session, we will learn about operations on data structure and abstract data types. So far we have seen the introduction of a data structure, classifications of a data structure. So this is our third session on data structure and algorithms, DSC. So here we will learn first operations on data structure. So what is operations? We know what is data structure. What is operations? Operations means any action that you can apply on a data called operations. Suppose if we have a number, then what we can do with the numbers? We can add one more number in that one. Like if it is a 5, then I can add 3 into that one. It will become 8. Or if it is a 5, then I can make subtraction from that one by 2. So like that I can do some operations on this data. I can make a addition, subtraction, deletion, or in the same way so many operations we can do. But if it in case of a number, I can do addition, subtraction, multiplication, division. So these type of operations I can do. So particularly this is a database data type specific. Addition, multiplication, that is a data type specific. But in generally, if I say I have to do the operations on data, then what type of data operations I can apply in general? So that we will learn first. So operations that can be performed on various data structures, that is, first one is traversing. What is traversing? Suppose if I have a record. What is record? You can recall that one. In the first session we have learned that one. What is record? Record is a set of data items. Records is, what is record? You can see from here. A record is a collection of data items. What is data items? More than one data that is combining into a single unit called a record. For example, name, address, scores and marks obtained are individual is a data items. This is a data items, and collection of a data items called a record. So here traversing means we have a record. We have a collection of data items, and traversing means to access each data item. Traversing means to access each data item exactly once so that it can be processed. For example, to print the names of all the students in a class. That is what? That is traversing. Okay, so this is meaning of traversing. Traversing is nothing but the iterating all the data items of a record, or visiting all the element at least once to process, called traversing. Okay, next one is searching. Searching is different from traversing. Searching is used to find the location of one or more data items. Searching is used to find the location of one or more data items that satisfy the given constraint. What is constraint? If I say give the name of student whose age is less than 28, it means, or 25 or 23, whatever criteria you will decide. Or take another criteria, Give me the names of student whose roll number is less than 20. That is a constraint. Either less than this one, greater than this one, or you can say that is a condition only. So, searching is used to find the location of one or more data items. What is data items? We have just read. Data items is single data item that will make one record, that is data items like name, address, mobile number, like that. Okay. So, searching is used to find the location of one or more data items that satisfy the given constraint. Such a data item may or may not be present in given collection of data item. Yeah, that is the chances whether you are searching for you are searching for a particular record, but that record might be present or might not be present. It depends on the in the record. If record has that that data item, it will return, otherwise it will not return. Okay. So, such a data item may or may not be present in given collection of a data item. For example, to find the names of all the students who secured 100 marks, very less chances. How much the marks you are getting in your college or university marks? 100 or not 100, might be, but very rare chances the student will got all 100 marks, 100 out of 100, very less chances. You might get 99, but 100 I don't think so someone will get, very rare chances. So that record definitely won't be there in data in the record or in the data structure. So that is a searching. Next one is insertion. What is insertion? You want to add new record. Inserting is nothing but the insertion operation. You want to add a new data item. Used to add new data item or items to the given list of a data item. So, for example, to add the detail of a new student who has recently joined the course. You want to add, you can add. So, this is called insertion. That is nothing but that operation is used to add new data item to the given record or given collection of data items. Okay. Next one is a deletion. Similarly you can insert, you can do the deletion operation also. Means to remove or delete a particular data item from the given collection of a data items. For example, to delete the name of student who left the course. Delete the name of student who left the course. That is a deletion operation. Insertion, you want to add new record. Deletion, you want to delete the existing record. So that is deletion. Next one is a sorting. What is the meaning of sorting? You want to sort the record, no? You want to sort the record, or you want to sort the collection of data items, or sorting is nothing but the arrangement only. Suppose you wanted to sort the students, all the students by name. First should the name will become that who's starting with letter A, then whose name starting with letter B, C, D, like that. Or you want to sort by roll number in ascending order or in descending order, however you want. That is your choice, that the constraint you will define. How I wanted to sort, how we wanted to sort, that we will define. But that operation sortings can be applied on data structure. So the data item can be arranged in some order like ascending order, descending order, depending on the type of application. For example, arranging the name of a student in a class in alphabetic order, or calculating top 3 winner by arranging the participants score. Yeah, that is also chances, depending on depending order and then extracting the top 3. So like that we can sort, that is our choice. I wanted to sort by name, sort by age. Yeah, that is also choice. You can sort by age, you can sort by name, you can sort by roll number, you can sort by what is that one, the winning score, you can sort by winning score, like that. So that is sorting operation. Next one is merging. Merging means two data items or collection of two data structure you want to combine into a single one. You can do generally in C or C++ or Java, we do these operations. We do what? We create a list or set, and inside that one we can add the existing list or set. Yeah, we can add, no issue. So that is nothing but a merging. List of two sorted data. It's not like that. It should be sorted. It depends. You might have sorted or you don't have sorted. Then also you want to merge. You can merge. Merge means merge only in a single. You want to merge. Okay. Can be combined. Data items can be combined to form a single list of sorted data items. Many a time two or more operations are applied simultaneously. You can apply two or more operations simultaneously also while merging. For example, if we want to delete the details of a student whose name is X, then first we have to search. If we want to delete the students whose name is X, then we first have to search the list of students to find whether the record has X exists or not. If it exists, then at which location, so that it can be deleted from the particular location. So while merging we might need to do more than one operation. Suppose don't add the record, don't merge the record if the record is already present. If the data item is already present in that list, don't add. That is a criteria, or that is up to our choice. We want to add still, yeah, we can add. So that is the another operation on data structure, that is a merging. Merging is nothing but combining two records in a single one. Okay. Fine. So these all are the operations on data structure. Next one is abstract data type. What is the abstract data type? First time we have heard about data type and abstract. Abstract means the specifications only. Implementation will not be given. Abstract means the specification will be given only, not the implementation. Implementation has to be provided explicitly by implementing the interface in Java. So that is abstract. Data type, we know what is data type. The data that we want to store, we have to tell what type of data we want to store, and while storing the data we have to tell what type of data and how much memory it will take and where we have to store. So that much we have to define. So that is called a data type. And abstract data type is what now? Now what is abstract data type then? An abstract data type is a way to look at data structure. Suppose if I have an integer number, I have taken this example just now when we started this session. I have an integer number. What can I do with that integer number? I will define the operations on that integer number. I can define. Yeah, it is already predefined. On integer, you can apply insertion, updation, deletion, addition, subtraction, multiplication and division. On integer data type, you can apply these type of operations only. But suppose if I have created a student object, then what type of operations I can apply on that one? You can't apply an addition or subtraction or multiplication or division. You can't apply on that student object. or customer object or person object or any other object that you created. Or if you take the example of a string class, can you apply an subtraction or multiplication or division operations on on string? You cannot apply, because that is not applicable for that one. So abstract data type means how we are looking on data, and focusing what it does and ignoring how it does. Suppose, for example, stack and queue are the perfect example of abstract data type. Stack and queue, what stack can do? Stack has a push and pop, queue also has a push and pop operations. So it will just consider, if it is a queue, we can do two operations only. If it is a queue, then push and pop, stack, push and pop, like that only. So we can implement both these ADTs using array and linked list. Okay. To know more about abstract data type, let's split both. What is data type? Data type of a variable is a set of value that the variable can take. We have already read the basic data types in Java, including int, char, float, double, boolean, long. So these are the basic data types. So that is a data type only. When we talk about primitive data type, built-in data type, we actually consider two things: a data item with certain characters and the permissible operations on that data. For example, an int variable can contain only the whole number. Integer, if it is an integer variable, definitely it can contain only the numbers. If it is a boolean, then definitely it will contain only true and false. If it is a float, then it can contain, other than whole number, some fractional part also it can have. Okay. And can be operated on these operator and can apply these operations: addition, subtraction, multiplication, division, like that. In another word, the operation that can be performed on a data type are the inspirable part of its identity. In other words, the operations that can be performed on data type are an inspirable part of its identity. Means the operation itself will define the data type sometime. That is the meaning of this line. Okay. Therefore, when we declare a variable of an abstract data type, we also need to specify the operation that can be performed on it. Simple. If you take the example of Java. In Java, we will generally create the classes. In classes, what we will do? We can create the object for that class now. What operation we can apply on that object? We have to define. If it is an student object, then definitely what we have to define? How many operations we have to define? Set student name, set student roll number, set student course, set student ID, get student ID, get student course, get student roll number, get student name. That operations we need to define. So this is only, it is telling here, when we declaring a variable of an abstract data type, that can be a stack, queue, or whatever you want, we also need to specify the operation that can be performed on it. So that is data type here. Next one is abstract. You can now clearly understand what does it mean of abstract data type. Abstract means the word abstract in the context of a data structure mean considered apart from the detailed specification detailed specification or implementation. In C, an abstract data type can be a structure considered without regard to implementation, and it can be thrown off as a description of a data in the data structure with a list of operations that can be performed on a data within the data structure. So simply in C we have a structure, we know that structure is there, we can define the structures. Operations we will define separately, but in Java how we will do? We have just generally we define interfaces. That is in the abstraction only, 100% fully 100% abstraction only. Okay, so in the same way, if we define any data, the meanings to say this one, the meaning of this one, abstract data type means whatever the data type we will specify, we must define the operations. Okay. The end user is not concerned about the detail how the method carry out their task. Simple, that's only. In abstraction that will only be happen. They are only aware of a method that available to them and are only concerned about the calling those method and getting the result only. Same thing we will do with the abstract interfaces in Java. In interfaces we will just define the specifications or abstraction. Implementation will not be provided. Implementation whoever will be provide, that will be another task, and whoever is going to call that method, their concern is not how the internally that method is working. Okay, they are not concerned about how they work. For example, when we use stack or queue, the user is concerned only with the type of a data and the operation that can be performed on it. This line is clearly telling, when we use stack or queue, the user is concerned only with the type of data and their operation that can be performed on it. Therefore, the fundamentals of how data is stored should be invisible to the user. If you take the example of our list, you know, in Java we have a list. Let's take list of string. List is equals to new list, array list or linked list, whatever you wanted to use. So here if you apply list.add, what it will do? It will just add the element to where? Element to this list only. You know how exactly it is adding? You no need to know. Definitely you if you want to know, you can know. You can just inspect, but here this is just a specification only. Implementation is where? Implementation is provided in array list. And here if you search for add, you will get to know how it is adding. It is doing some operation. It is sending this here, it is adding, it is checking lengths, otherwise length is less than something, it will grow, like that it will do. So this is called abstraction here. So therefore the fundamental of how the data is stored is invisible from user. They should not concerned with how the method works or what structure are being used to store the data. They should just know that to work with the stack, they have a push and pop function. Here we just know, here add, remove, delete functions are there. Add, remove, delete functions are there. Similarly, if I create if I create here class of student student, definitely this is a student. Now let's forget about this one. Create here a student object. Student s is equals to new student. Now what type of operation can be applied on this student? Or create a separate class you want to create. So what type of operations can be applied on this one? You have to define like get message, public string, get message, anything, whatever you wanted to define, you can define. Anything. So this is what it is doing. Now you are defining get message, you are defining the operations here. Your concern is not what exactly this is doing. So in the similar way, you just have to define, you just know what to work with the stack. They have a push and pop functions available to them. Using these functions, they can manipulate the data, insert, deletion, or any other operation they can do. So this is about abstract data type. What is abstract data type? Abstract data type means defining the function with the declaring of data type. Whatever the data type you will define, you have to define the functions for that, or you have to define the operations for that. That is abstract data type. And the best example of a data types are stack and queue. Okay, so this is about abstract data type and operations on data structure. So in the next session we will learn more about algorithms. In the first session we have seen what is algorithm. We just see the definitions. What is algorithm? What will be the structure of algorithm? But algorithms can be defined in some steps. We will know how we can create, how we can write an algorithms. What should be the structure of an algorithms? If we have to give some conditions, then how we will write in our algorithms. If it is a loop, how we will write the algorithm for that one. What is the approach to write the algorithm? If you have a problem and you know the solution, then for that solution, how will you write the algorithm? How will you start the writing algorithms? So that one we will learn in the next session. So I hope you like this session. Please subscribe my channel and we will see you in the next session. Till that, bye bye and thanks for watching.